Chapter 5, Probability. Session 5.1, what is randomness? For these sessions, we will talk about the random number table and also what is the empirical and theoretical probabilities. So first, what is randomness? Randomness means having no predictable pattern. For example, when I flip the coin, I can get head or tail, but you won't be able to predict what do I get for the next one. Okay, so this is called random. People are not good at creating truly random samples or random experiment. So if I ask you, hey, I may get head or tail when I flip the coin 10 times, can you just create a random samples for me? So you may say head, head, tail, head, tail, head, head, tail, 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 head, something like that, right? We say people are not really good at creating a random numbers because usually people seldom to create 4 to 5 consecutive head or tails. Even though we do, you may not believe this is a random number. So we usually want to use the technology just like your computer or calculator to generate the random number. If we don't have the technology here, so we could use the random number table. Okay, let's look at it. What is a random number table? So look at this example. You're gonna see this is the random number table. We do have a different 9 here, and then we do have a different numbers here. Okay, let's perform an experiment. We're gonna stimulate 20 coins total. So it means I want to flip the coin like 20 times. And I want to record what I'm gonna get. Do I get the head or do I get the tail? I will be using this random number table to generate the head on tail. So in this example, we want to use the row 30. Row 30 is talking about here. So we want to use this number to generate 20 coin toss. So let's circle it. I do have a 5 on each, so we do have a 20 numbers in here. Now, we're gonna let odd number be the head and even numbers be the tail. Okay, so first one, I got the 9. 9, this is an odd number, so we got the first head. 0, we're gonna consider that's an even number, so we have the tail. And then 5, which is gonna be odd number, so I got another head in here. And then even, and then odd. So I want you guys do it by yourself. For the rest of the 15 numbers, just write it down. Will it be the head or the tails? Okay, check your work. So we use the random number table to stimulate 20 coin toss in here. Okay, question. What is the longest streak of head or tail in your data? The streak is talking about any sequence of consecutive heads or tail. So you're gonna see we do have 3 head here, 4 head in here, and this is the 3 tails. So the longest streak will be these 4 head. Okay, 4 heads in a row. So this is the example how we can use the random number table to generate your experiment. Okay, probability. Used to measure how often random events occur. When tossing a coin, the probability of a head is 1/2 or 50%. This means that the coin will land on the heads about 50% of the time. So this is the probability. We need to know how to calculate the probability for each event. And then we do have 2 types of probability. First one, this is called theoretical probability, or some other books saying this is a classical approach. Second one, that's called empirical probability. Okay, Let's look at it. What's the difference between these two types of probability? First, let's talk about the theoretical probability. This is talking about the long one relative frequency. This is talking about your answer, your probability. When you get the result, this is talking about the long one relative. Second, the relative frequency at which an event occurs after infinitely many repetitions. For example, if we were to flip a coin infinitely many times, exactly 50% of the flips would be heads. So this is talking about when you perform experiment, when you flip the coin, you're not flipping about like 10 or 20 or 30 times. You may want to flip the coin about like 10,000 or 100,000 times. And then based on the result, we're gonna calculate the probability. Theoretical probability of an outcome is the relative frequency if we repeat the action infinitely many times. But of course, we know that that's impossible. You could flip the coin infinite many times. And that's why dynamics say theoretically. You can imagine, we pretend we flip the coin 100,000 times. We'll be using a computer to generate 100,000 times of the result. And then we're going to calculate it. How many times will be land on the tails? And then we'll be calculate the probability. Okay, so we'll keep repeating like this experiment. We find it out. You do have a 50% chance to land on head, and 50% chance is gonna be land on tail. Of course, we assume you do have an equally chance to land up the head or the tail. And then we get a number. Finally, we say, okay, 50% will be head, 50% will be the tail. So you could think about it, theoretical probabilities is always using the calculation. And they do have exactly the same result. No matter how many times you're gonna calculate the probability to getting head or tail, the answer will be the same. 50% of the head, 50% of the tail. Okay, so this is the idea for the theoretical probabilities. For the next one, empirical probabilities. Relative frequency based on an experiment or on observation for a real-life process. Example, I toss a coin 10 times and I get the 4 heads here. So the empirical probability of getting head is I do have a 4 heads over the 10 times I flip the coin. So that would be 0.4. That's a 40% to get on the head. So empirical probabilities is based on the experiment. Okay, so the result every time will be different. So if I flip the coins 10 times, I may get 6 head this time. So the empirical probability getting head will be 6 over 10, which is 60%. So one more time, we do have two types of probability. First one is a theoretical. Second one, that's an empirical. Theoretical is using the calculation to find out the probabilities. So every time we're gonna get the same answer. But for the empirical probability, that is based on the experiment. Since this is the experiment, so the result every time will change. Okay? Okay, theoretical versus empirical probabilities. Theoretical probabilities are always the same value, just like I say, right? Because we're using the calculations. So the example is when you're tossing a coin, it's always 50% to get the head. Empirical probabilities change every experiment. So if I toss the coin 10 times and I get 7 heads, so my empirical probability for getting head will be 70%. Stimulation. Stimulation is a way to model random events, such that stimulate outcomes close match to the real-world outcomes. By observing stimulate outcomes, research gain an insight of the real world. One experiment with the real-life process are too expensive and time-consuming. So if the stimulation is close enough to match to the real life progress, then the relative frequency from the stimulation can be used as the empirical probabilities. And for the empirical probabilities, if the number of trial is large enough, and then we could keep repeating the progress of the empirical probabilities, and finally the stimulation will be really really close to the theoretical probabilities. So at the beginning, we don't know about if getting head will be 50% when you flip the coin. So what can they do? They're gonna perform the empirical probabilities. So they may try to get large number of the trials for the empirical probabilities, and then we're gonna calculate what is that probability. And then we try to keep it large number of the trials and keep repeating the same experiments. And then we find it out, the answer getting head will be 50%. So you have the idea that when you flip the coin once, you will have a 50% to get the head. Okay, so this is how they think about the formula for the theoretical probabilities. And then random number table. This is one of the tool for the stimulation. And actually, we usually use the computer to generate the number more than the random number table. You also can use your calculator to generate the random number as well. I'm gonna teach you guys this part later on. That's it.